This is the Digital Key, Season 3, Chapter 3. In this episode, we will be talking about path convolution and the arrow of time in relation to dual valence. It is clear that when two digital streams in a single vessel split into two vessels, one of those vessels experiences a distinct arrow of time than the other. That is, although the same time passes during the substitution period for both vessels, for one that time flows more quickly than the other. Path convolution does not just occur within infinite recursion, where each more convoluted path experiences a different and ascending arrow of time. Path convolution is also a product of the absence of nonlinear intersections within the path of a vessel. This means that each nonlinear intersection eliminates some portion of convolution from a path, while at the same time accelerating the experience of time in that path. This is relevant to dual valence, because in dual valence one of the structures is in negational valence with the complementary analog structure. This means that it takes two nonlinear intersections to produce two phase flips to bring that stream into an affirmational valence. At a minimum, bringing three structures with two digital streams and an analog structure out of dual valence requires a single nonlinear intersection. This means that even in the barest case, one digital stream will have greater path convolution than the other. However, in order to shift a negational valence pairing between the analog structure and one digital stream to an affirmational valence, requires two nonlinear intersections producing phase flips in both structures. In this case, the two digital streams will describe distinct persons. In other words, to move between the conformations with dual valence, flipping the streams in the first and third structure requires three nonlinear intersections, but in that case digital stream 1 and 2 overlap in their experience of time after the phase flips. Likewise, when two structures are in affirmational valence, it results in resonance amongst those structures. In other words, shifting a negational valence pairing into affirmational valence doesn't just alter the arrow of time in that stream, it also represents a return to the digital key for those structures. This also tells us that path convolution is restored by three nonlinear intersections amongst three single-person digital structures. In other words, the number of nonlinear intersections it takes to maintain path convolution is equal to the number of structure members. When all three structures are unaligned, that is not in affirmational valence or negational valence, there are three streams describing three distinct persons, two digital and one analog. From the initial starting point of dual valence, a single nonlinear intersection is required to produce three streams amongst three persons. That's the end of the podcast for today.